pages, and so I don't think it's
Right, it is 9 o'clock, and I noticed that the class has gotten a little bit more compact. There are spaces in between now. You can space out a little bit more. Like we have an entire row here without anyone. So
just the rain.
just the rain, maybe not.
If you look at your roll sheet, what does that say?
The row sheet says there should be more people. But I don't know. All right. But I cannot wait for people to show up to start the lecture, so I'm going to get started right now. So what we'll do today is I will try to answer any questions that you might have regarding the homework assignment, the one that's due on Monday. So are there any questions about that particular homework assignment? Any concept questions?
It was just a little bit more work than from the previous homework assignment, but it was okay.
Okay.
It takes
Yeah.
a little bit more time.
It takes a little bit more time because there are a few things you kind of have to think it through first. Okay, so what you need to do is to think of a particular input, and then you have to be able to work it out by hand first, and then go, okay, when I see this, I will recognize this is not a number, and then what do I do when this is not a number? So you kind of have to think it through and do it by hand a few times. Then you can say, okay, I think I have the general pattern, and then you look at all the tools, all the components that we have available, like a while loop, scanf, a few other components, and go, okay, how do we put all of these things together to do what I just did by hand? So that's basically the essence of your programming is you have to know the tools well, the components really well, and on top of that, you have to kind of have an idea of what the program is supposed to do as well. And then it's just a matter of, how do you put all of those things together. Yep.
Can you go over how to use the test files?
The test files?
Yeah.
Absolutely. Okay. So what I'll do is I'm going to illustrate how to use the test files. So let me go to the news forum first, okay? Because just in case someone does not get the memo, I'm going to show them where to find it. It's in the news forum. It is the last one that I sent out to everyone, and there's a little file attached to the message. So what you want to do is to download this file into Windows and then upload this file onto the virtual machine. So are you done with that part? Okay, so you have to get this file onto the virtual machine, and I would put it into the same folder as the code itself. So the folder readnum, okay, you have to put this file into the readnum folder first. And you can use WinSCP to do that. If you're running Linux natively, then there's no issue. You just save the file and put it into that folder directly. Okay, so what I'll do is I'm going to pretend that I have a folder like that in my home directory. So I'm going to make a folder here. So I'll just make a readnum as a subfolder, okay? And I want the file to be in readnum, but since I'm using Linux already, all I need to do is to save the link into the folder, and I'm all done. So the folder is readnum itself. Okay. So the objective is when you look at the readnum subfolder, you should be able to find the file in that subfolder first. Okay. So once you have that file in the subfolder, you run the command that is already included in the instruction, which is this part here. Okay. Depending on how you use the virtual machine, you can copy and paste it if you use PuTTY. If you're using the console itself, I do not think there's a way to copy and paste it, but I could be wrong. Okay, so you can just go ahead and type it too. It's not a whole lot of stuff to type. So I would just go ahead and type it. It's tar space xzvf space and then the name of the file, and then you press the enter key, and it will basically decompress into 14 files. Are we still doing okay so far as how to decompress the file into the 14 files? It's basically a zip file. Okay, tar.gz is kind of like a zip file in Windows, except this is more of the standard that people use in Linux as opposed to zip, which is a standard people use in Windows. So once you have these 14 files, each one is a text file. you can use your favorite text editor to take a look at each file, to see its content. Some of these files are empty. So the first thing I would do is to do an ls, which is showing details of the files, and I would do a ls-l, which is the long format of ls, and take a look at everything that starts with test. And you can see that there are 3 files, or I should say 4 files, that are actually empty. When you see a 0, let me highlight which 0 we are talking about here. When you see a 0 in this column, it means that file is empty. There's nothing in the file. The files with an extension of .in, those should serve as input file into your program, and the files that has .out as an extension should serve as the output from your file, from your program. So what I'll do is I'm going to try to do the homework assignment, and obviously this will be the incorrect solution. So do not copy and turn it in, because this is not going to be the right answer. Okay, so I'll go ahead and do it, just so that you know how to run the program and how to test the output of your program. Okay. So I'm going to go back to my own assignment here, and just put this program into a file. And it's supposed to be main.cpp, so I'm going to use the same file name. And we'll do a paste, Control-D, build, get rid of all the leading spaces, 1, 2, 3, 4. And okay, so this is what I'll do, with this particular program. And I'm going to do it the wrong way. Okay, so don't copy this code at all. Parts of it may be useful, but in general, this is not very useful. Okay, so I'm going to do a scanf %d with the address of x, and then I'll do a scanf of %c with the address of ch. And I'm doing it without any conditional statement. This is obviously incorrect. Okay. And then on the output here, I'll just keep it the same way here. All right. So there we go. And I'll go ahead and compile the program, g++-g. I'm not going to debug it, but I'll just put it in anyway. And we'll link the program. So, and the way you run the program is like this. Okay. So you want to run the program with the name of the executable, and then redirect standard input from a .in file. Okay, so those are basically all test cases for you guys to try out. So if I want to run it on a test, let's say test3.in, okay, this is how I do it. Now, if you just redirect the input, the output would still be on the console, which means you would still be able to see the output of this program, and it prints 1 in this case. Okay. On the other hand, if you want to capture your own output, then you can redirect the output using the greater than symbol. So in this case, I'm redirecting the input from test3.in that will serve as my standard input file, but the standard output file will now be captured to the file that I am going to specify here. Okay, so you can say my test.out or my test3.out. Okay, like that. Okay, so the output is no longer being sent to the console, and you cannot see the output because it's now captured in the file called mytest3.out. Are there any questions about these steps? So this is one quick and easy way to run your program using one of my test input. So what you need to do next is to compare your output with my output. Okay. And there are several ways to do this. If you want to do it the basic way, you can use nano or vi and just take a look at mytest3.out. Okay, it has a single 1 in it. And then you can do the same thing with test3.out, which is the standard answer. It has 1, 2, 3 in it. So in this case, the program that I just wrote has the incorrect output, and I have to go fix the program. Okay, it's an indication that there's a problem. If you want to get fancy, you can use a special mode of using VI. You can actually display 2 files, side by side, so you can actually see, oh, okay, this is the output of my program, and this is what it is supposed to be. Okay, To do that, you say vim, and then use dash uppercase O. Okay, this is not a 0, it's uppercase O, and then you specify the two files. My test3.out, which is the file that I just created, as opposed to test3.out, which is the correct answer to this particular test case. Press the enter key, and now it is displayed side by side. The left-hand side is the actual output of the program that I wrote, which is incorrect, and then the one on the right-hand side is corresponding to the correct output of this particular input file. So this gives you a really kind of easy way to compare, okay, what is this input supposed to send out as the output. Now, if you want to get super fancy, okay, this is the super fancy way to do it, is you can also include test3.in as a part of the command line. So now it will open up in 3 columns, and that's the output. Okay. Are there any questions about this part? And you can do the same thing for test 1 all the way up to test 7. There are 7 test files. Any questions? Anything I can answer? Yep. Can you do this one? In Nano? Yes, you can. Well, Nano, I'm not sure whether Nano can open up multiple files in the same screen. If that is your question, the answer is no, I do not know. Okay, I just know that for sure this can be done in VI. Okay. Any other questions?
Can you go back to the other screen?
To the other screen, to the browser?
Yeah. No, to the where you type in the console button.
You mean the command to do this?
Yeah.
Like that?
Yeah.
Okay. Now, this program is obviously wrong for a particular reason. If you look at the actual source code of this program, it has to be wrong. It doesn't even matter what is the code inside the subroutine. Okay, let's take a look at main.cpp and see if you guys can catch that error. Okay, first of all, I should have used the option -wall, uppercase W and ALL, because it would have caught the problem. Look at subroutine readnum, okay? What is the return type of readnum? What kind of a value is it supposed to return? An integer, okay? And where do I specify the integer to be returned? There are no return statements, right? If there are no return statements in C and C++, this subroutine will not specify a particular value to return. Now, does that mean there's no return value? No, it has a return value, you just don't know what it is. It turns out to be 1. And that's why I printed 1, okay? So if you change this and say, oh, okay, that's a problem, and say return X, now it would return something different. It would work for test case number 3 in this case. Okay, so let's take a look. Okay, so we'll go through 512, 513, and then run the program again. So that would be this. There you go. So I'm going to rerun the program and then look at the output of this program again. And this time, hey, we got it. Okay, this is the input. Oops. This is the input. This is my output from the test program. This is the actual correct answer as an output. So this time they do match up correctly. Okay. But if I compile the previous program with -wall, it would have warned me that the return type of that subroutine is supposed to be an integer, and I'm missing a return statement. It would have complained about it. All right. So this little session has already illustrated a few things, okay, that might be related and helpful to your homework assignment. So did I answer the question about how to use the sample input and output?
Yeah.
Okay, excellent. If you download Vim in Windows, it will be able to open multiple columns as well. But that's really just a fancy feature. You can always just look at each individual file separately and be able to do that. Okay. Any other questions? Yep.
I have a
question about the code for this one. How come when you're initializing the subroutine read num, you don't like list any parameters in there?
Because it does not need anything in. The standard input file is not a parameter. It is just there. So when you use scanf or printf, scanf will automatically read from the standard input file. Nobody has to tell it that. That's its behavior. And then printf by itself will always print the standard output file because that's the way the subroutine works. In fact, since you asked that question, when you pop up the man page of scanf, for instance, it will tell you, okay, scanf is a member of a family of subroutines. So these are all basically within the same family. But when you read the details, okay, it will tell you that the scanf family of functions will do all this stuff here. But it will also have one specific description of scanf itself. It says this function reads input from the standard input stream, stdin. So this one is implicit. It already knows where it is reading the input from. Okay. That's a good question. But the answer is, it's because scanf automatically reads from standard input file. There's no need to pass any parameter to tell the subroutine what to do. There's nothing as an input to that subroutine. Okay. Any other questions? No other questions? All right. If there are no other questions, we'll go ahead and proceed and not talk about cin, the cin way of doing the same thing, with error correction. I'll wait until the current assignment is due. I'll give you the solution to this one, and then we'll talk about how to do it using cin, the object-oriented way. So what we'll do instead is we're going to move forward a little bit to talk about pointers today. We touched on pointers in the previous class, so today we'll kind of continue with that discussion and talk a little bit more about pointers. Before I go, I just want to have one last question. Is there anything else you guys need to ask about this particular homework assignment? Yep.
Can you explain the part of your code? What does in the program? And how
Which
our code?
Which code in which program?
The part that we cannot change.
The part you cannot change.
From.
This is the only part you can put something in. So you can insert as many lines of code as you want between line 3 and line 5. If you want to use your own subroutines, go ahead. You can define and call your own subroutines as well.
So can you explain the main function?
The main function?
What does it really do?
Okay, well, the main function only makes use of things that we already understand. It has a do-while loop. This is the do, this is the while, which requires one single statement in between, right? And the statement that is in between the do and the while is one single block of statement. It starts with this open curly brace, it ends with this curly brace. Is that okay so far? So with a do-while loop, we are performing whatever is inside, and then we check the condition and say, okay, after performing all the actions, do we want to go back? Okay, because if this condition is true, then we're going back and perform the action again. Inside, we have a function call to read num, which is something that you are going to write. It will return an integer, which I store into local variable x. And then I say, if it is not the end of file yet for standard input file, I'm going to print out the value of x using printf. And then I could check this condition. If it is not end of file, it will go back and try to read the next number. In other words, in English, what this is really doing is it's saying, do read a number. If it's not at the end of file, print that number out as long as we are not hitting end of file. That's all. That's what it's saying.
So the code that we're supposed to put in will pick out the letters, basically?
Yep, that's what the description says, right? Okay, so let me see here. Okay, about read num, this is the specification of read num itself. the readNum function, which is what you're going to write, is going to read in a base 10 integer using scanf. However, it also needs to detect input errors, which means, okay, what if you encounter something that cannot be the beginning of a base 10 number? And then you also have to be able to recover from that input error. So the trick to do that is to rely on scanf. Reading the man page of scanf, you realize it returns the number of items properly parsed. In the event of an input that cannot be parsed as expected, scanf returns a number that is less than the number of items to read. This is an indication there's an error. To recover from an error, readNum needs to dispose of the character that is not what it expects. This can be done in a variety of ways. However, since we are talking about scanf, we'll just go ahead and use scanf for this purpose. Is that okay so far? Because I'm just reading my own description here. In addition to reading multiple digits as a number, scanf can also read individual characters as follows. Okay, so you define the local variable here inside the scope, so ch cannot conflict with anything else, okay, in this case. And I just use scanf %c in this case to read in a single character. So it's not going to read in, like if you have 1, 2, 3, it's not going to read in the character 1, the character 2, and the character 3. It will only read in the character 1. Because it's reading in byte by byte. Is that okay? Because that really is an important concept, okay? You know, when you're reading in character by character as opposed to reading in a whole base 10 number, one is trying to read as many digits as possible as an integer, and then the other one, which is this one here, is just reading in the character, okay? If there's a character left, it will read that character. Okay, so I further explain variable ch is of char type, a character, which essentially is a byte or 8 bits, okay? It is more than just a very short integer because a character is also the quantum of a text file, which is basically, this is the smallest unit you can read in a text file. As such, scanf has a special mode using the format string %c. This paragraph is an explanation of this little code here. Are there any questions about this chunk of code? Nope, okay. So after readNum clears the character that is causing a problem, then you have to make readNum reattempt to read a number again. So you have to basically do it again and say, okay, can I read the rest of this input file as an integer? If you can, great. If not, you have another character to dispose of. There's one stop condition that readNum has to detect as well. When there's nothing left in the input file, readNum should stop attempting to read anything, okay? Not a character, not a number, and simply return. In this case, the return value of readNum is meaningless. It is up to the caller of readNum to first check whether end of file is reached before making use of the return value of readNum. So this is also something that we talked about last time, is when you read the man page of scanf, especially when you go to the return value part, which is kind of all the way down here, okay? It says the value EOF is returned if the end of input is reached before either the first successful conversion or matching failure occurs, okay? In other words, if you call scanf when you're already at the end of the standard input file, it returns the constant called EOF, which is actually just -1. Okay? Is that okay so far? So use the return value of scanf wisely, because that can help you decide, am I getting out of the loop? Am I staying in the loop? Or what else should I do, after that? Any questions about that part? Now, the actual finished product can be surprisingly concise, okay? It is a little bit longer than the previous homework assignment where you have to find a prime factor given a number, but it's not really a whole lot more than that. So the key is really to understand each piece individually and then find out, okay, how do I combine all of these pieces to do what the program is supposed to do? So am I addressing the question? Okay. Now the other thing you want to do, is use my test files before you even write the first line of code if you have not started yet. Do not even start the first line of code until you have seen all the test files, because some of these can be, a little bit interesting. This is one of the test files. So what if the end user types, this is a whole lot of gibberish, but where's the integer, question mark? Okay. Do you see any base 10 integers here? I don't. So what do you think is the output of the program? Nothing, right? Empty file should be the output, because you would basically look at T and say, that's not the beginning of a base 10 number. H is not the beginning of a base 10 number. I is not the beginning of a base 10 number. And I can keep saying that all the way up to the question mark on the second line, right? But after the question mark, what do we get? EOF, right? End of file. What do I do when I detect end of file? I just say, I'm giving up, right? Readnum is going to give up. But when readnum returns to main, what is the first thing main going to do? Not counting, putting that readnum return value into X. What is the very next thing it's going to do? Check end of file, right? If it is already at end of file, what is main going to do? It will skip over the conditional statement, and then it will exit the loop without printing anything. So that's why when you look at the output corresponding to test6.in, test6.out is the proper output. Oops. Test6.out. It is empty. It's absolutely empty. There's nothing here. It's not even an empty line. There's nothing here. There's no line feed character, nothing. Okay. So what you want to do is to do something like this. You really want to look at all the test files, because all of these are here for a reason. Okay. So what about the output of this file? It has 100 as 100 as a number. It has 1 and then a 0 and a 0. So the output should be 4 lines, okay? 100 on one line, 1 on the second line. The third and the fourth line both should have 0. Okay? So now with that knowledge, okay, about what is the test input and what is the expected output, then you can think about your code a little bit more carefully before you write it, okay? A common practice, not necessarily a wrong one, is people would look at the general output of a program and sit down and start coding right away. Okay, some people can do that. Some people can actually think in C and C++. Okay, some people cannot. Okay, but my recommendation is to do everything by hand first. Okay, and figure out, okay, this is where I'm reading next. This is what I'm going to read next. What am I going to do? And then use that to help guide your coding, because that will really help you understand, oh, okay, this is really repetitive, because I have to toss away this character, toss away this character, toss away this character. If it's repetitive, it's suggesting that you need to use a loop. Now, as soon as you know that you need to use a loop, the next question to ask is, how am I getting out of the loop? Okay, I would ask that question right away, even not worrying about what is inside the loop. Once you know the condition to get out of the loop, then you think about what is inside the loop. What is each step of this iteration? Okay, what is being changed for each iteration, so that eventually I'll be able to get out. So that's my usual way of thinking, and everybody thinks a little bit differently. And this is a somewhat creative process. Okay, nobody described programming as a creative process, but it is a synthesis process. Okay. So it's not like creative as in art type of creative, where this is a new way to show a particular thing. Okay, that's art. But in programming, you still have to put things together, and it's a synthesis process, and everybody thinks a little bit differently. So you kind of have to figure out what is the best process for you to think about your programming. Because if you're on the computer science track, this is what you'll be doing 40 hours a week, at least. At least. Because for some of you, you will like doing it, so you'll be doing 60 hours and not even know it. And for some of you who may not enjoy doing this, you'll be working 40 hours, but you think that you have worked 80 hours. So it goes in both directions. You've got to find an occupation that fits your personality and your, for the lack of a better word, knack. Does anyone know the word knack? K-N-A-C-K? Okay, what does that mean? And I see some nodding. What is a knack of doing something? Well, not just enjoy, but also
Like subconscious, right?
You have a good ability to.
aptitude. Okay, the more formal word is aptitude. So knack is an ability, a talent, or special skill needed to do something. Otherwise, if you ask IBM, which is all formal suits and stuff, they will say this is aptitude. Now, if you search online, I'm sidetracking a little bit here, but it is not a complete waste of time because you can look up IBM programmer aptitude test. Okay, and someone, okay, and I have to remember, you can look up images because somebody actually took pictures of the good old IBM programmer's aptitude test. If you score really well with those questions, or if you enjoy doing those type of questions, you are probably well suited as a quote-unquote programmer, which is not exactly what you want to be, because you want to be a software engineer, not a programmer in the next few years. Okay, those two job titles are related, but not exactly the same. But for the most part, what makes a person a good programmer also makes that person a good software engineer, or an engineer in general. Okay, so you want to look at these. Okay, I'll just look at one. Okay, since we're here, we'll just look at one. All right, so let's zoom in a little bit here. This is not an eye chart. I'm not checking your vision. Okay, find the rule in each series and indicate a choice which completes the series. In other words, if the series is 19, 23, 27, 31, 35, 39, what is the next number? That is what it's asking. What do you think? C is 43, and that is correct, because from what we have seen in these 6 numbers, the spacing between the numbers is just 4. Okay, so this one is pretty easy. Okay, this one is 3, 4, 5, 3, 4, 5. What is the next number? 3, exactly. This one, even people who are musical were able to figure this out, right? Because it's mi fa sol, mi. So there's a pattern to it. Okay, next one. This one is more fun. 53, 58, 54, 59, 55, 60. What is the next number? 56, right? Okay, because it's going forward and then going back the same, going forward by 5, going back by, let's see, going forward by 5 and going back by 4. So that's the pattern. So this is one test. If you look at some of the other ones, like this one here, okay, it's not even in words, right? So this one is asking you, A is a small black square. When it's changed by the rule, make it larger. We have B. Okay. Now look at C. Is a small black circle. When it's changed by the rule, make it bigger. The correct answer. Okay, this is just a key. It's instruction for the questions. So the actual questions is here. I like these. Okay, so in A, okay, we have the 2 circles, A, B, okay, and now you're presented with a square C. The question is, what is going to match C the same way B is matching A? That's basically what the question is. What do you think? 2, exactly, the other half, right? If you look at number 2, we have A, and then we have B, and then when you look at C, what is going to match C the way B is matching A? 3, that's right. Okay, so this is the kind of stuff that that IBM used to use. I'm not sure whether they still use it or not to test aptitude for programmers. And one thing you can say about IBM is, whatever they use, especially when they use it consistently, has to be working. IBM is really kind of pragmatic when it comes to stuff like this. It's not going to do anything, if it's not working. Okay. So this is a good test, for those of you who want to, confirm that you are, picking the right, major This does not apply only to programming, it applies to any type of occupation that involves problem solving. So most engineering jobs, involve, problem solving. In fact, I would say that in some of the engineering, some of these are even more important because when you design gears or other things, the mirror image of something is an important thing. We don't get mirror images in programming, not much. Are there any questions about all of this stuff here, other than, why are we talking about this? This is not C++ programming.
But this is fun.
Well, if it is fun, that means you have the quote-unquote knack of into programming and computer science in general. All right. So now that that is over, any other questions about the homework assignment?
I just have one question. When you're in a Vim file, and let's say you just write some program wrong, and you want to end, and you want to clear all the Vim file, and it's like and you wrote about like a 50 line. Is there any command that you do in the Vim file
Undo?
that clear everything?
Okay, in VI there is an undo feature, which is just lowercase u. It will undo one step at a time. I have no idea what is the history depth that it can undo, but I have personally undone a lot of steps in a single session. But the thing is, if you exit out of Vim, you can no longer undo anything after you exit.
Can you
So,
select all? Can you select all?
select all
Yeah.
to do what? Select.
Well, he wants to delete the whole thing, so.
You want to undo the whole thing?
So I went, for example, I'm in the Vim file, I did like a 50 line program. I did it wrong. So I go back and I want to just rewrite it again.
Okay.
So I just don't want to go to the backspace and backspace button on my
Oh, you mean
keyboard.
you want to nuke the whole thing?
Yeah, yeah.
You can just remove the file. You can say rm in the file name. That will remove the file itself. But that's not a Vim thing. It is a shell thing. So you have to do it in Bash. You can use rm to remove a file. I'm sorry. I misunderstood your question.
All right. No problem.
Okay. All right. Any other questions related to the homework assignment? Any questions? Okay. Nothing is more important than getting started early and getting the right information in your mind first. Okay. I talked about this with a particular student in this class in the previous lab session. Writing a program is kind of like a slow cooker. Okay, it's like slow cooking. If you want to end, okay, so let's say you're leaving the door and you want to have beef stew when you come home after work. Okay, well there are several things that you need to make sure that happens, right? First of all, you need to get the right ingredients. Just putting potatoes and water into the slow cooker does not mean that you end up with beef stew. Okay? Well, unless you have magical powers, then it's different. Okay? But for those of us without magical powers, if you just put plain water and potatoes into a slow cooker, you're not going to get beef stew. You can get beef flavor stew if you just add some seasoning, but it's not going to be actual beef, right? No animal is actually harmed in this product, in the process of making this product. So you need to make sure that you have the ingredients. Now, the ingredients in programming are the concepts, okay? But you have to make sure that you get the right concepts, okay? You have to understand scanf, okay? What is scanf returning? What is the format string? What does it mean, okay? What is the difference between reading a base 10 number using %d as opposed to reading a character using %c? Those are the ingredients. What is a while loop? What is a do while loop? What is a conditional statement? What is a return statement? Those are the ingredients. You have to kind of make sure that you get all the ingredients. Now, now that we have talked about the test files, those are the extra ingredients, okay? Because you look at this input, this is the proper output. Okay, this is the input, this is the proper output. That is important as well. So you put all of these ingredients into your slow cooker, which is your mind, okay? And you get started early. Your mind has ways to solve problems when you're not even thinking about it. But you got to make sure that you have all the ingredients in first. So from time to time, you can go back and check with your mind and say, oh, slow cooker, are we done yet? So you can look through the glass lid and go like, well, it's still stewing, okay? And then you go back and do your other things. But you have to check periodically because occasionally the slow cooker may be broken, right? It's unplugged from the wall. Somebody said, I need that outlet for something else and unplug your slow cooker. So you have to go back and plug it back in. So that's basically the equivalent to going back to the homework assignment and just to refresh your mind and go, oh, that's right, I have this homework assignment, I'm still thinking about it, okay? But you have to kind of keep it going. And a lot of times, the solution won't come right away. So don't be impatient with your own mind, because it might take you a little bit of time to put all of the components together and find out how to combine the components. Okay? But the key is your mind is a slow cooker. If you put in the ingredients like at 5:30 p.m., you're not going to get dinner done by 5:40. Well, at least mine is a slow cooker. I think some of you are smarter than I am, so you don't have as slow of a cooker. You have a microwave, and mine is just a slow cooker. I used to play the Go game with one of my buddies. So he would make one move, and then I would have to think a long time. At one time, he commented and said he could hear the stone grind turning in my head. That is how slow I am. All right. So now you know that you picked the wrong class. My professor is really slow. I don't want to deal with that. All right, so getting back to pointers, as long as there are no questions with the homework assignment. So with pointers, it is very important. It's a really, really important topic because this is how C and C++ is, okay, I consider those two as the quote-unquote same programming language, different from all other programming languages, okay? If you look at Java, there are no pointers. If you look at PHP, there are no pointers. Python, no pointers. Visual C#, okay? C# has no pointers. Visual Basic, no pointers, okay? C and C++ is pretty much the only programming language to date that is still in use that has pointers. Now, pointers can be very useful, but at the same time, it can also be very dangerous. Okay? So what I'll do next is to show you a particular subroutine that is intended to do something, but because of the lack of pointers, it's not getting it done. Okay? So I'll start with that example to illustrate the necessity of using pointers. So what I'll do is I'm going to give you a program, and I don't need to save it. So I'll call this program swap.cpp. It is supposed to exchange the values of two variables. And I want to do it as a subroutine, okay? So I want to do it as a subroutine, and the subroutine is not going to return anything. It will do the changes of the parameters in place. So if I have int x as a parameter and int y as a parameter, I want swap as a subroutine to exchange the values of those two parameters. I want y to end up with the original value of x. I want x to end up with the original value of y. That's the purpose of this subroutine. Now, the subroutine itself or the content of the subroutine is really easy. Okay, you can look it up online and say, okay, swap algorithm, and you will find it. So I'm not even going to spend a whole lot of time to explain it. You will need one extra local variable, we call it t, and then the trick is to save the value of x before you change it. Then you can go ahead and change x first by using y to change x. Now that x is changed, now you can say, oh, y needs to go get the original value of x, which was stored in variable t, and that's the sequence, okay? 3 assignment statements, and you're done. And some of you may still remember in the practice test and also in exam 1, both, we have a long, obscure, comma-separated expression that can also have the same effect as swapping or exchanging values, and you can put it in place of these 3 statements as well. Okay, but this program is not going to work. So I'll go to the main subroutine, and in the main subroutine, I have my local variables. I'll just call this v and w. Okay. So v starts with a value of 45, and w starts with a value of 63, and then I call the subroutine swap, okay? and I say, hey, go ahead and exchange the values of V and W for me, and then I'm all done, okay? So the intent is by the time I get to line 17, I want V to end up with a value of 63. I want W to end up with a value of 45. When you look at the swap subroutine, the code is correct, okay? There's nothing wrong with the swap subroutine. And just to make it easier to debug, I'm going to insert a totally meaningless statement, but this will give me a chance, well, the other way may be able to do it too. But this will give me a chance to examine the variables by the time we are done with line 7. So that's the whole intent of line 8. It's not really useful by itself. All right, so here's my program, and I'll go ahead and compile the program first. Okay, swap.cpp, and we'll go ahead and link it to, so -o, swap.o, and gdb the program. Just like most of our other programs, this program cannot be, if you run it on the command line, it's not going to do a single thing. So we'll put a breakpoint on line 15 first, run the program, and we'll just do it step by step, okay? I just ran line 15 and 16. We can print V, and we can print W, okay? They're as expected, okay? So when we call the subroutine, the first argument, which is V, is going to specify parameter X. The second argument, which is W, is going to specify parameter Y. So when we single step at this point, we go into the subroutine swap, and as expected, parameter X now has a value of 45, and parameter Y has a value of 63. The value of parameters are specified by arguments in the invocation of the subroutine. And the invocation in this case is in the main subroutine itself. Okay? So now we go through the process of the swap logic here, and by the time we get to line 9, it actually understood that line 8 is useless. So X now has a value of 63, which is correct, and Y has a value of 45, which is also correct. So everything seems to be working. So someone already knows, oh, no, that's not working. And we single step back into the main subroutine, and then we look at local variable V and local variable W in main, and go like, hey, what's happening here? These two are not affected, but the parameters got swapped. Why is it not working here?
No return statement.
Well, there's no return statement because swap is not supposed to return.
Two separate locations when you sent it to the function.
Exactly. Okay. Now I'm hoping some of you still remember when I said parameters are like local variables. So what is about parameters or local variables that makes them kind of special? They do not exist until until the subroutine is invoked. Okay? And what happens after the subroutine returns?
They go away.
They go away, exactly. That is the most important part you have to remember about parameters and local variables. They do not exist until the subroutine is called or invoked, and they go away immediately after the subroutine returns, and that's it. So all the work that we have done with parameter X and parameter Y is gone when the subroutine has returned. Parameter X and parameter Y of swap has no actual relationship with local variable V and local variable W of main, other than we used V to start the value of X, we used W to start the value of Y. That's the only time they are quote-unquote related. After that, they're completely separate. Are we still doing okay so far with that concept? Because this is really one of the most important part of subroutines and understanding parameters and local variables.
When you say they go away, does that mean they're completely they're deleted from memory, or they don't matter anymore in the new or back in main?
That's a very good question. The answer is, one, they are no longer accessible, okay, because the scope we're out of the scope. That's one thing. Two is even though they are quote unquote still on the stack, or they're still in memory somewhere, okay? But there's no guarantee that area in memory cannot be overwritten by something else. So you cannot count on local variables that are quote unquote gone to retain the value where it was before. Okay? You can kind of imagine that in memory there's a line that keeps changing, and anything to one side of the line is guaranteed to be preserved, but anything on the other side is quote unquote in the recycle bin. So it's the same thing as you put something into the recycle bin, okay, where you have no control over the pickup schedule. Okay, so you clean up your desk, okay, and you say, oh, I don't need this piece of paper, I don't need that piece of paper. You put it all into the recycle bin, and you put the recycle, trash can out, right? And then suddenly you realize, oh no, I just put my homework assignment that's due tomorrow into the recycle bin. You run out to the recycle bin. Well, it depends on how soon they come pick up the trash, right? Maybe it's still there, maybe it's not. It's the same thing here. Okay, once you put something into the recycle bin, which is what happens at the end of the execution of a subroutine, all local variables and all parameters are quote unquote put into the recycle bin. So there's a chance it's still there, but one, they no longer have a name so that you can access them, and two, who knows when the garbage truck is going to come around to pick up the trash. So there's no guarantee that those things will still be in memory or having the same content in memory anymore. So I'm hoping this helps you understand that kind of little thing. It's really hard to explain in this class. That concept will be explained in full by the time we get to cisp360, which is the assembly language programming class. All right, but for the time being, I'm hoping if there are any questions, go ahead and ask. But I'm hoping that everybody can kind of see that I can do anything I want to do with the parameters x and y, but nothing is really going to happen to v and w. Is that okay? How many people learned the term passed by value? Okay, this is passing by value.
So pointers would be a way to pass by reference for C?
Well, that's a interesting question. So we'll go to passing by pointer next. A pointer is technically passed by value as well, but the question is, what exactly are you passing? Okay, that is the question. Okay, so with that in mind, okay, we'll go back and change the program. In fact, I'll just kind of copy the original program to a new file, and then we'll save it, right? Okay. So I'm saving this file, and then now we can go back and change swap.cpp. Okay, so the fix to this using the concept of a pointer is like this. So instead of passing an integer into swap, I'm passing a pointer to an integer in the swap for both parameter x and parameter y. Now in this class, I will not enforce any type of naming convention, but one of the naming convention thing that people use is when you're passing a pointer, you use lowercase p as a prefix of the variable. So I'm going to use px and py here. T is still okay because it is not a pointer. Okay, and so we'll go ahead and make one mistake first. And this is an intentional mistake. I will let the compiler complain about it. Okay, so I'm now passing by pointer, and I changed the names from x and y to px and py accordingly, and I think I'm done. Okay. And I'll go ahead and let the compiler figure out, okay, are we done yet? So gcc or g++ -w all -c-g swap.cpp, and it has a lot to complain. Okay, and the complaint has to start with line 5. Okay, invalid conversion from int asterisk to int. Now, when you look at int asterisk, it means it's a pointer to an integer. When you look at int, it's just an integer. So what is the difference? What is the difference between a pointer to an integer as opposed to just an integer?
The pointer is the address where the integer is stored, not the integer itself.
Itself, that's right. Okay, so the difference is the same thing as a reference number of a book in the library as opposed to the book itself. Okay, an integer is the book itself, but the pointer or an address to an integer is a reference number of a book in the library. Is that making any sense? Sort of. A house versus the address of a house, same thing. Okay, a house is just a house, but the address of a house allows you to go to a particular house. So in this case, I'm not passing an entire house to the subroutine. I'm only passing a pointer or the address of a house to the subroutine. So the subroutine can get to the original house because it knows where to find the house. Are we doing kind of okay so far with this? Okay, so I'm just going to move forward because this will. I'm hoping the rest of the program will start to illustrate what we have to do here. So the next thing we look at is so it's complaining that we have a type mismatch basically on the two sides of the equality symbol, and the question now is how am I going to fix it? Okay, let's go back to the program here. Okay, the complaint has to do with what is the type of T. When you look at the declaration of T, what is the type of it? It's a regular integer. When you look at the declaration of parameter px, it is a pointer to an integer. So now we can say, okay, how do we convert a pointer to an integer to an integer? Well, there are actually several ways to do it, but only one way is the correct way. In this case, we are not referring to the pointer. I'm not really that interested in the pointer. I'm actually now want to refer to what the pointer points to, the content at the address. So now I need what we call a dereference operator, which is a single asterisk, which can be confusing because the asterisk means two things. When you look at the declaration of the parameter, int asterisk something means it is a pointer to an integer. But when you look at, so this is px, but when you look at px and then you apply the asterisk operator to px, it means we are dereferencing px. In other words, we are now getting the content at px, content that is pointed to by px. We are actually using the call number to go to the library to retrieve the book with the dereference operator. Any questions? Yep.
Sorry, but I kind of I still don't realize what's the difference between those two.
One is this one is the type of the parameter. This one is an operator applied to the parameter. So one is a type, the other one is an actual operator. And say, okay, here's a pointer, what do you want to do with it? This is what we are doing with the pointer. This one is simply saying px is a pointer to an integer. So this is a declaration, this is an actual use of the parameter. Are there any questions about this? If you look at a pointer as a phone number, okay, that might work also. If you look at a pointer as a phone number, then this is basically just saying px is a phone number, okay, area code and then 7 digits. But it's just a phone number. This is actually saying, oh, call this phone number. So this will allow you to talk to the person on the other end, with this particular phone number. This one is just saying, oh, here's a little slip of paper with a phone number on it. Use px as a phone number. This one is saying, oh, actually make use of it, okay? Go ahead and call. Is that doing okay? Okay, yep. This is going to be the example. So what I'll do is I'll finish the program first, and then we'll go ahead and run it in GDB, and then in GDB you will see actually what is happening. Okay. So the next few ones, we have to do pretty much the same thing, Because once again, I am not swapping the addresses, I am actually swapping the content pointed to by the address. Okay. So over here, I'm no longer passing V and W, I'm actually saying the address of in that case. So address of and dereference are canceling operators. Because one is taking the address of something, and the other one is saying, go to that address and I want the content at that address. So that means if you have something like W here, you can actually do this, do this, do this, do this, do this, do this, and do this. And this whole thing is just the same thing as that. Because the two operators are canceling each other. Okay, this is W, which normally refers to the value, the content of the variable. This is the address of W. This is saying, oh, give me the content at this address, but whose address is that? W's, right? So this is basically going back to the value of W, the address of W, the content of W, the address of W, the content of W, back to the address of W. So that's why you can extend this as much as you want, and it doesn't really change the meaning, as long as the last one is an ampersand, which is the address of. Any questions about this? Okay. No questions? Okay, so if there are no questions, we'll go ahead and retry the compiling of this program and see if it compiles first. So we'll go ahead and say G++. Hey, compiles, that's good. We'll go ahead and link it, and then we'll run this program in GDB step by step, okay? We gotta be sure what we are doing here. So, -o, swap, swap.o, GDB swap. Okay. And once again, we put a breakpoint in main, okay? So as soon as we get into main, we're gonna stop, and then we can single step. Okay, so now we run the program, we stop on the first line. Not very exciting, not very exciting. This one is kind of exciting. But before we even go here, we want to say, hey, I think GDB is smart enough to understand what is ampersand. Why don't I do it right now? In other words, I'm going to say, hey, give me the value of V, okay? 45, not surprising, right? Give me the address of V. And as it turns out, GDB understands how these operators work as well, which is really helpful because now we can say, oh, the address of V is BFFF9B4. That's the phone number of this particular variable, or the address of this particular variable. And it doesn't change, okay? Forever and ever, as long as main is alive, this is going to be the address of local variable V for this particular instance of main. Are there any questions about this? But what is actually an address? You know, it's 0xBFFF9B4, but what exactly does it mean? It's just an integer in base 16. That's all it is. Every single byte in a computer, in RAM, has an address. And the address is nothing more than an integer. 0 is the address of one byte. 1 is the address of another byte. 2 is the address of another byte. This turns out to be just be a big number, okay? Because this is all in base 16. So if you want to look at the actual address, like in this case, as a 32-bit number, you can do the conversion, right? How many people still remember the conversion from base 16 to base 2 using the table of 16 entries? At least the approach, okay? You may not remember the exact entries in the table, but the approach is to take one digit in hexadecimal and convert it into 4 individual zeros and ones. So in this case, we have B. B is 1011, and then we have 1, 2, 3, 4 Fs. Each one is 1111. And then we have 9, which is 1001. And then we have B, once again it is 1011. And then we have 4, which is 0100. This is just an integer, okay? A 32-bit integer. That is the address of the starting point of variable v. Are there any questions about this part? No questions? Yep.
What if you have like a really big amount of RAM and you run out of numbers?
Well, this is good for 4 gigabytes. So if you have 16 gigabytes, then you will need to have a 64-bit operating system, which will give you a 64-bit address. Now, even with a 64-bit address, it simply means this is going to be a longer number. But the approach is still the same.
I always wondered about that.
Yeah, a 64-bit platform versus a 32, implicitly speaking, is, 32-bit platform has a 32-bit address bus, which means, any address can only go from 0 to 1, 32 ones as a binary number, which turns out to be about 4 billion something in decimal. And then when you're dealing with 64-bit, obviously you have a lot more addresses. People used to think that we will never use more than 2 megabytes of RAM with any type of computers. They look at a 20-bit address bus and go like, wow, that's a lot. That's like 16 megabytes and we'll never run out. And guess what? We ran out. And then people go to like 4 gigs of RAM, 32-bit address bus, and go, oh, we'll never run out ever. We have 4 billion, built 4 billion bytes now. And guess what? We ran out too. Okay, so 64-bit address bus will just take longer to run out, but I'm pretty sure, I have confidence that we'll run out as well. Okay, so are there any questions about what we are seeing in GDB at this point? Okay, now since W is a different variable, we can probably expect it to have a different address. And sure enough, it has a different address. When we're dealing with 32-bit integers, how many bytes are there in each integer? There are 8 bits to 1 byte, so a 32-bit integer will take up how many bytes? 4 bytes. Look at the addresses of W and V. The ordering is not important, but how far are they off from each other? Exactly 4 bytes. Okay, so everything has a reason, and if you pay attention to the details and try to think about, but why are they off by 4 bytes? You will actually start to gain understanding of stuff that is not explicitly stated in this class, but you'll start to notice things. It's like, oh, okay, why is it like that? There's always a reason. It's not random. Okay, so now we can single step into the swap subroutine, but this is going to be important as well, because as soon as you single step into swap in GDB, it will now tell you that PX is an address and PY is the other address. Are those numbers the same as before? They are the same as before. We pass the address of V to parameter X, PX, and the address of W to parameter PY, and they are exactly like that. So PX and PY are no longer actual integers. They are now addresses of integers. Are we still doing okay so far? Okay. So the next step is T gets the content at PX. Okay. So what we can do is we can say print dereference PX, because GDB understands the ampersand, which is what we call the address of operator. It also understands the asterisk operator, which is dereference operator. Okay, the content at an address. And guess what? Hey, that's just 45. That looks familiar. That was the value of V, right? If you do the same thing with PY, it still has the content of 65. Yep.
So if you just said print PX, then it would just give you the address, but because you did the asterisk, you get the value.
Exactly. And this is one thing that GDB can visually display that is much harder to explain otherwise. Because GDB just tells you, hey, PX is an address, and asterisk PX is just an integer. Okay, it's really kind of obvious. It's visual. Okay. Are there any other questions about this? I'm very tempted to give you some extra commands in GDB, that is related to taking a look at content of memory, but I'm kind of deciding against it, because it can just be adding more confusion at this point. So I'm kind of not do that part. All right. So we'll single step the first instruction. And what do you think after we single step line 5? What is the result of this statement? T ends up with what? 45, right? Because it's not the address, it is the content that we store into T. Okay, this is our next instruction, or the next statement. The next statement is basically saying, follow the pointer py to the location. Grab the content at that location. It becomes the right-hand side of the assignment. But I'm not storing that content into px, the parameter. I'm storing that to whatever px points to. So in this case, when I execute this statement, line 6, okay, should I expect px to change the parameter itself? Would it still be the one before ending with b4, or will it change to the one that ends with b0? If I just say print px,
Still the same, right?
Still the same, right? Because it's just I'm not changing the phone number. I'm asking the person at the other end of the phone number to say, oh, I want you to remember this number now instead of the previous number. Okay?
Can you repeat or just give an example?
Okay, think of it like this. Okay, so so let's say you are a variable, and I'll pick you as the other variable. Okay, so that means you can store a number, you can store a single state. Okay, so let's say that you are both integer, so you have a little post-it to write down a number, but you can only remember a number at any particular time. So I'm asking you to write down 45 on your little post-it, and you have to write down what 63 on your post-it, and then I'll get your phone number. I'll get your phone number. Okay. What is being done here is swap as a subroutine is being given the phone numbers of both of you. Not 45, not 63, just your phone number and for your phone number. Are we doing okay so far? So inside the swap subroutine, I have my own little post-it, which is T, and T actually is an integer as well. So in the first step, which is line 5, I'm going to highlight which line here so that you guys can focus on that one line here. So with this line, I'm calling, okay, who has the 45 again? Okay, you got a 45? Okay, so I'm calling you using your phone number, okay? PX is your phone number, and the asterisk symbol means call, okay, and get the value. So I'm calling you and go like, okay, look up your little post-it and tell me what number you have. And you answer 45, right? And then you hang up. So I write down 45 on my little post-it, which is T, which starts with some kind of random, nonsensical value, but now it has 45. The second line, which is line 6, is a little bit more complex because there are 2 phone calls involved in this step. The first phone call is to you, okay? The other phone number, right? So I'm going to call you and say, okay, tell me what is on your post-it. And you answer and go like, 65, okay? But 65 is not being stored anywhere else. I'm just remember, okay, 65, I hang up the first phone call. And then for evaluating the left-hand side of what is highlighted on the projector, I'm calling you again, okay? And say, oh, go ahead and update the number on your post-it to 63. Okay, so you are going to end up updating 63. Did I change the phone number of either one of you? No. I'm just asking you to change not the phone number, but the number on your post-it. Are we doing okay so far? Okay?
So you're asking him to change his number, you're asking him to change my number, but
right.
we don't change our phone numbers.
Exactly. Yep.
So if you've done px equals py, would that have switched the addresses then?
That is correct. In that case, okay, as far as swap is concerned, it has 3 post-its. 2 post-its are parameters, and 1 post-it is a local variable. Are we doing okay? T is my local variable, which can only store an integer. But guess what? I also use post-its to write down your phone number and his phone number. So I can choose, okay, which is incorrect in this case, to overwrite the phone numbers themselves. But that would not serve me any good because my intent is to change the post-its of you guys, not to change the phone number. You had a question?
Yeah.
Yep.
So if you told the program to switch addresses, would they keep their numbers still?
Exactly.
Okay.
Yep, because I'm not switching their phone number, I'm only switching the phone numbers on my post-its.
Okay.
Because I write down phone numbers on the post-it as well. And one post-it is called PX and the other post-it is called PY. And they start off with 2 phone numbers, but I can always exchange the phone numbers within the post-its, but that's going to be useless because at the end of a subroutine, what do I do with all my post-its? To the recycle bin, right?
So in other words, like for example, number 63, the digit 63, it has a physical address, but that can never be changed like physically. Only like, for example, if we play around with the swap function and we swap the addresses instead of the.
It doesn't change the content.
It doesn't. Okay, I see.
Because the address is the phone number. In other words, I have 3 post-its. As a swap subroutine, I have 3 post-its. I can erase and change whatever I have, on my post-its. Would it change the number that you have on your post-it?
No.
No. Would it change your post-it? No. Because when I change my post-its, it's not even a phone call. You guys would not even know that I have been messing around with the phone numbers on my post-its because I'm not calling anyone. So until you have the asterisk symbol, the dereference operator, I'm not even placing a call. So I'm just playing with the phone numbers themselves that is in my own little phone book.
Right.
It doesn't do a single thing to the person on the other side, let alone the post-it or the value of that person. Are we doing okay so far? So I learned something new today. I have learned that using phone numbers is actually a better way to explain pointers than many other ways of explaining the concept. And the reason is because we all have phones. Using the other concept, a reference number. When was the last time you look up a reference number to go to the library to get a book? To me, it was probably 92. Yep. And some of you are way too young because you're 92. I wasn't even born yet, right? So that's how old I am. But you know what? C++ has not changed much since then. So you guys are good with that. All right, so this is the last one. The last one is to look up my own little post-it that had the original value of what you had, and then I'm making a call to you and say, okay, well, first of all, I look up my own little post-it, T, and go like, oh, it has 45 on it. Okay. Then I call you, because your phone number is on the other post-it called PY. So I use the phone number on PY and call you, and then what I will say over the phone is, update your post-it to 45. So at the end of all of these operations, you end up with a post-it with 45 on it, and you end up with a post-it with 63 on it. Oh, but hold on a second here. What do I do with all those post-its? Because I'm in the subroutine of swap, I have 3 post-its, 2 are phone numbers, and 1 is just a number, right? So what do I do next? Toss it all into the recycle bin.
Yeah.
Is it really okay? But isn't that going to destroy your post-it and your post-it? What am I really destroying? Am I destroying your post-its, or am I destroying just the post-it with your phone numbers on it? Just a post-it with a phone number, which doesn't do a single thing to your post-its. If I destroy, a slip of paper with your phone number on it, would it also destroy your telephone? No, because it's just a phone number on a piece of paper. I'm destroying the paper, not the phone. Okay? So when I single step, oops, right there, then we are all done. Okay? So this is a good place to take a look at everything again. Have I changed PX compared to what PX used to be? So when you compare PX and PX at this point, has it changed? No, PX itself has not changed. I have not changed the numbers on my little slip of papers. when you look at whatever px points to, the value at px, that has changed. Okay, which is the intended result. Okay, so if I single step and get out of swap and get back into main, now I can look at v and I can look at w, and they are now in fact exchanged. All right, is that okay so far? It's all good? So here's the question. What if I give swap the wrong phone number? Hey, I can cast anything into a pointer. Okay? In other words, if I do something like this, okay, okay, I'll just make it less confusing. I'm going to make it like this. Obviously, the compiler is going to complain and say, hey, 45 is an integer value. It is not even a phone number. Okay? But I can cast it. Okay? I can do something that is called casting. In other words, I can always convince the compiler that I know what I'm doing. And 45 is in fact a phone number, and so is 63, when they're actually not phone numbers. Okay? This is called typecasting, which basically means, even though 45 usually cannot be considered as an address or phone number, I can tell the compiler and say, hey compiler, I know what I'm doing, just consider 45 as a phone number. But it's not an actual valid phone number, right? What happens when you make a call to a non-phone number on your phone? You get a tone, do do do. This is not a phone number, da 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 da, right?
Yes.
And guess what? When I run this program, it will do the same thing, without the tone, without the entertaining part. So let's go ahead and take a look. 510. Okay, that's fine. It's just complaining. Okay, that part is okay. 511. And this time when I GDB the program, it's going to have a little bit of a problem. But the question is, when is the problem going to show up? Okay, so let's go ahead and put a breakpoint in main and run the program. Single step, single step. These two should not be a problem. When I single step here, that's no problem either, because all I'm doing is writing down 45 on a piece of paper, give it to swap and say, yeah, that's a phone number. And I'm writing 63 on a different piece of paper, give it to swap and say, this is the other phone number. That alone itself is not a problem, right? Because I'm not placing a call yet. So as a result, when we get into swap, hey, px and py have some really kind of small value. It's tiny, right? 2D, as it turns out, is 2 times 16 plus 13. What is 2 times 16 plus 13? 45. This is the hexadecimal representation of 45. Not surprising, right? 3f is 3 times 16 plus 15, which is 63. Okay. So at this point, the swap subroutine has two phone numbers on paper, and the first one is 2D, the other one is 3f. Are they actual locations where I'm supposed to find something? No. But it's not going to have a problem until I try to execute line 5, which is basically using px, the phone number on px, and say, call this number and tell that person to tell me what is on his or her post-it. And guess what happens? Since it's not an actual real phone number, this happens. It's called a segmentation fault. Okay? Which is equivalent to I cannot remember in Windows how it's called. In Windows, I think it's called an exception of some kind. They have changed the name over the years. Okay, in the earlier Windows version, they would give you an exception and tell you that it's gibberish to most people, but that's basically what it is. Is we are trying to use an invalid phone number and call that location, go like, hey, I want to access this location, but that location actually, quote unquote, does not exist, or it is not accessible by your phone. All right. Well, we are running out of time today. That clock is actually a little bit slow, so we are actually over time a little bit. I don't have anything structured during the lab time, so it would just be you working on your homework assignment. So for the most part, I'll just be looking through the glass lid of slow cookers. And occasionally, if you want me to stir something, I'll go ahead and stir it. Okay. Any questions about that? But I don't have a slow cooker. Nobody told me this class requires a slow cooker. All right, I'm going to stop the recorder at this point. I'll upload it as soon as